All right, adventurers, get ready to level up because today's quest is all about unlocking the secret language of every computer, phone, and gaming console out there.
I mean, have you ever really stopped to wonder what's going on inside that little black box? When you're in a game or sending a text, what language is that machine actually thinking in?
Well, I can tell you it's definitely not English. In fact, every single photo you take, every song you listen to, every password you type, it's all stored in a secret code, a hidden language that, no joke, powers our entire world.
And the coolest part, it's a language so simple, you're going to learn the basics in the next few minutes using nothing but your own two hands. Ready? Okay, let's dive in.
So first things first, what exactly is this secret code and why on earth do computers have to use it? It's called binary, and it only has two symbols, 1 and 0. That's it. And the reason is actually super simple. Computers run on electricity. So for a computer, everything is either on, that's a 1, or it's off, that's a 0. The whole thing is basically just a giant system of billions of tiny light switches.
Okay, now for the really fun part. We are going to turn your right hand into a tiny 5-bit computer. Each one of your fingers is about to become one of those on or off switches, or what we call a bit.
All right, get that right hand ready. Check this out. Each finger has a value. Your thumb is worth 1. Your index finger is 2. The middle is 4. You see the pattern here, right? Each finger is just double the value of the last one, all the way up to your pinky, which is worth 16. So if a finger is up, it's on, and we count its value. If it's down, it's off, and it's just 0.
Okay, first challenge. How would you show me the number 21 using just your right hand? Think about it. Which fingers do you need to flip on to add up to 21?
Let's walk through it. To make any number, you always start with the biggest value that can fit inside it. For 21, the biggest is 16. So, pinky up. Now we have 5 left to make. The next biggest that fits into 5 is 4. So, middle finger up. We just need one more. And hey, that's your thumb. So you've got your pinky, middle, and thumb up. In the binary code, that looks like 10101. You see that? You're literally speaking computer right now.
But hey, that was just level 1. What about bigger numbers? Well, for that, we're going to need to bring in your other hand. It's time to level up.
The exact same pattern just keeps on going. Your left hand picks up right where the right one stopped. That doubling pattern continues. Your left pinky is 32, the ring finger is 64, then 128, 256, all the way to a massive 512 on your left thumb.
All right, new challenge. 2 hands this time. How do we flash the number 73?
We use the exact same strategy. What's the biggest number that fits inside 73? That'd be 64. Your left ring finger goes up. Okay, that leaves us with 9. What's the biggest number that fits into 9? That's 8. Your right ring finger goes up. And what's left? Just 1. So your right thumb goes up. There it is. Left ring, right thumb. That's 73 in binary.
So, what's the highest number you can possibly count to with all 10 fingers held up? A whopping 1,023. That is a ton of information to store on just 10 fingers.
Okay, I know what you're thinking. Counting to 1023 on your fingers is a cool party trick for sure. But why does this actually matter? Well, because understanding this simple system unlocks some serious real-world power-ups.
Your first power-up is a big one, cybersecurity. Knowing binary shows you exactly why your teacher is always telling you to make longer passwords. Just look at this. With only 3 bits, or 3 fingers, you only have 8 possible on-off combinations. But with 8 bits, which has a special name, it's called a byte, you suddenly have 256 combinations. Every single bit you add doesn't just add one more option, it makes the code exponentially harder for someone to crack. It's not just a rule someone made up, it is pure math.
Power-up number 2. You're going to understand how video games actually work under the hood. When developers are coding a game, they need a super efficient way to track all of your abilities and power-ups.
And they do it with something called bit flags. Instead of wasting space with tons of separate trackers, they can use one single number, where each bit, each finger basically, is a switch for a different power-up. Is the first bit on? Cool, your shield is up. Is the third bit on? You've got a speed boost. It is an incredibly clever and efficient way to store data.
And finally, you get the ultimate power-up. This gives you a kind of X-ray vision. You can now see how computers actually store information at the most fundamental level. Remember how a byte is 8 bits? Well, that means the highest number it can hold is 255. This isn't just a random number, it's the reason why old-school game characters were often made of 8 by 8 pixel squares, and it's why you sometimes hear about overflow errors in coding. A number literally tries to go past 255, and the computer runs out of bits. It runs out of fingers to count on.
Okay, let's bring it all home and tally up our final score here. What's the real big picture takeaway?
Look, learning to think in binary is way more than just a neat trick. It's like learning about inches and feet for the physical world. Binary is the fundamental unit of measurement for everything digital, from the size of a file on your computer to the actual strength of your password.
You have officially unlocked level 1. So what's the final boss? Well, cybersecurity experts use this exact skill to design and build the firewalls that protect our entire digital lives. The internet is built on lines of ones and zeros, and now you speak the language. So you ready to learn how to build the walls in our next explainer?